Okay, so when copper 2 chloride reacts with sodium nitrate, copper 2 nitrate and sodium chloride are formed. So copper 2 chloride can be represented by CuCl2, reacts with sodium nitrate, which is NaNO3, because nitrate is a polyatomic ion with a -1 charge, and sodium is +1 charge, and you crisscross, you get one of each, and it forms copper 2 nitrate. You would need 2 nitrates to compensate for the +2 charge in copper, and sodium chloride, which is a salt. Okay, now we need to balance it before we go ahead and do the rest. So let's see. Copper looks balanced right now. Chlorine, I will put a little space over here. And put a 2 here. So now we have 2 chlorines. Chlorine looks balanced. Sodium, we need to balance that, so put a 2 here. And now it looks like everything is balanced. We have 1 copper on each side, 2 chlorines on each side, two sodiums on each side, and 2 nitrates on each side. So now we can go ahead and do the rest. I'll leave this here. Okay, so if 15 grams of copper 2 chloride react with 20 grams of sodium nitrate, how much sodium chloride can be formed? So we need to find the limiting reactant, and I'll use both of what we're given to find that. So we can start with 15. We always start with like what we're given. So 15 grams of copper chloride, and my OCD wants me to get rid of this. Okay, so 15 grams of copper chloride, and we need to convert that to moles of copper chloride. So the molar mass of copper chloride, let's see, copper is 63.5, I believe. I believe it's 63.5. Hold on, let me check real quick. Hold on. Yeah, copper chloride has so 63.5 grams in copper, grams per mole in copper, and 35.5 grams per mole for each of the chlorides. So 35.5 plus 35.5, that would be 71. 71 plus 63.5. 71 plus 63.5, that would be about 134.5 grams of copper chloride in 1 mole of copper chloride. Now we would use the mole ratio. Let's see, so we have 1 copper chloride. Then we have to find out sodium chloride. So two. Okay, I forgot moles. 2 moles copper chloride and 2 moles of NaCl. Now we convert NaCl back to grams. So let's see, sodium is 23 grams per mole, chlorine is 35.5 grams per mole. 23 plus 35, 23, 35, 58.5 grams of NaCl. I will leave that for later. 20 grams. Let's do with sodium. Same thing with sodium nitrate now. So 20 grams of sodium nitrate. Sodium is 23 grams per mole. Nitrogen 14 grams per mole. Oxygen 16 grams per mole. 48 plus 14, 62. 62 plus 23 is 85. 85 grams of sodium nitrate per mole of sodium nitrate and we set up the mole ratio. So let's see, there's 2 moles of sodium nitrate, and we need to convert that to sodium chloride or table salt. 2 moles NaCl. Convert that back to grams. Yeah, we use 58.5. Okay, now I'm going to go get my calculator and calculate each of these. So 15 over 134.5 times 2 times 58.5. That's about 13. That's about 13 grams of NaCl. About. Let's see, let's do it for sodium nitrate. So 20 over 85 times 2 over 2, which is 1, times 58.5, which will get you 13.776-ish grams of NaCl. So after calculating both of these values, the one that gives you the lower value is the limiting reactant. So we see 13 is less than 13.76. And what do we see here? 13 grams of sodium chloride is associated with the copper chloride. So the copper chloride is the limiting reactant, and we use what the limiting reactant value gives us for the product. So there are only 13 grams of sodium chloride can be formed instead of 13.76 that we have here. So the answer for part A would be 13. My calculator says 13, about 13.05 grams of NaCl. Now we'll delete all of this now. Hold on. Almost done. Almost done. Almost done. Okay. Part B. How much of the excess reactant is left over in this reaction? Okay, so the excess reactant we found it was sodium nitrate, and we found that it was 13.76 grams of NaCl that was produced from what is it? 20 grams of sodium nitrate. From 20 grams of sodium nitrate. And to calculate the excess amount, how much of the excess reactant is left over, we do leftover equals total minus what reacts. So we start with 20 grams of sodium nitrate. So 20 grams. No, we convert here. To find out what reacts, we convert the limiting reactant to the excess reactant. So we found that the limiting reactant was, no, actually, let me recall. Use the limiting reactant. You even need you don't even need to find what the product is. You just use the limiting reactant. So 15 grams of copper chloride. We found that the mole mass was 134.5, I believe, grams of copper chloride per mole of copper chloride. And then we can convert that to moles of sodium nitrate. So we just basically to find out what reaction you convert the limiting reactant to the excess reactant. So we do 1 mole of copper 2 chloride reacts with 2 moles of sodium nitrate. And again, I'm just getting this from the balanced chemical equation because there's an imaginary 1 over here, and I use this too. And 1 mole of sodium nitrate, we said that there was 23 was 48, 62, 85, right? 85 grams of sodium nitrate. Okay, so we just calculate this. 15 over 134.5 times 2 times 85 grams of sodium nitrate. And we were left with 18.959 grams of sodium nitrate. So this is what reacts, but this is not what's left. That is not what's left over. We see in the problem that 20 grams of sodium nitrate is what reacts. So we do 20 minus 18.959 equals what is left over. So 20 minus 18.959 equals 1.041. and that is what how much of the excess reactant is left over. So about like, let's say like 1.04 grams sodium nitrate left over. That is part B. Get rid of all of this again. Okay. If 11.3 grams of sodium chloride, if 11.3 grams of sodium chloride are formed in this reaction, what is the percent yield in this reaction? So you need to know percent yield equals the actual yield over the theoretical yield multiplied by 100%. So the actual yield, it's this 11.3 grams of sodium chloride. And the theoretical yield is what we found earlier. We found that it was 13.05 grams of sodium chloride. So we can just put this in the formula. So percent yield equals 11.3 grams of sodium chloride. Sodium chloride. 11.3 grams of sodium chloride. 13.05 grams of sodium chloride. Multiply that by 100%. And you should get 86.59% yield. And that is it.